Welcome to Section 5E. I haven't prefaced it for a while, but as a reminder, you should be reading this section before watching the video lecture. You'll understand more and get more out of the lecture this way. Section 5E, Roman numeral 1, we're talking about correlation. Correlation exists between two variables when higher values of one thing go with higher or lower values of another. Examples: height and weight, price and demand, or practice time and skill. Correlation does not mean causation. A scatter diagram is when every point represents values from two variables and it shows the relationship between them. And each variable is assigned to an axis. And I'm going to show you that in Microsoft Excel quickly. Here I have some information typed out about the per capita personal income for different states and also the percent of population below poverty level. To create a scatter diagram or a scatter plot, I'm going to highlight these here and come up to Insert and to my scatter. There we go. Now I can change this to be the percent of population versus poverty level for different states. I can also change my formats over here, or I can go back to the original and go into Layout and give myself different axes and change and put things in here. In this case, this is per capita personal income, and so forth. Now, when I look at this, this is showing the relationship between the income and the poverty level, the percent below poverty level for each of these states. Let's go back and talk about the correlation now. Different types of correlation. There are three different types of correlation. The first one is that no pattern is occurring to the scatter plot. This means there's no correlation or zero correlation. There's a possibility of an upward slant. This is a positive correlation. This is when one is increasing while the other is increasing, and the closer these make a line, the better the correlation. If it actually creates a line, then it's a 100% correlation, or 1. Notice the no pattern was a 0. If it's 100% and it actually forms all of the dots form a line, then it's a 100% correlation. The last one is a downward slant. This is a negative correlation. This is when one increases, the other is decreasing. Talking about the strength of correlation, the more closely the two variables follow the trend, like we talked about, making a line, the closer it creates some sort of a line or a trend, the stronger the correlation. 100% correlation, the points are actually creating that perfect line. And that 100% correlation can either be a positive line or a negative line, where one is increasing, the other is increasing, or one's increasing and the other is decreasing. Let's talk about, or look at this scatter plot. This is about inflation and unemployment. So entered into Excel gave me this scatter plot or scatter diagram, and I look at the correlation here. Now remember, if all of them fall in a line, it's a 100% correlation. I'm trying to find a line to fit in here and nothing's working. So this type of correlation, there's no pattern. So there's a 0 correlation or no correlation. Let's look at the next one. This is weather day forecasts. Over here I have the actual temperature versus the same day forecast. Over here is the actual temperature and the 3-day forecast. They're actually looking pretty similar. This one's a little more tight than this one, which would make sense. The same-day forecast should be a little more accurate versus the 3-day, but they're both following a trend going up in a slanted upward line, which would be a positive correlation. However, this one is definitely a stronger correlation than the 3-day forecast. And so I'm going to go ahead and put positive correlation as my answer and highlight it. And that the same-day forecast has a stronger correlation. It's forming a much tighter line. There are 3 explanations for a correlation: either a coincidence, a common underlying cause, sometimes we talk about it as a confounding variable, and one may actually cause the other. D, I have infant mortality and life expectancies in all of these different countries. Let's look at the correlation here. They're actually causing a trend. It looks like everything's going down nicely. It's not a perfect line, but it is definitely a negative correlation. That means as the infant mortality rate decreases, the life expectancy increases. Over here is infant mortality. This is life expectancy. Is this a causation? Is the infant mortality causing life expectancy to increase? No. So it's not causation. Is it a coincidence? I don't think so, but I do believe that there's a common underlying cause between infant mortality rate going down and life expectancy increasing. I would say it's healthcare. There we go, quality of healthcare. Let's look at our next one. Getting rich in the stock market. The stock market tends to rise as a team from the old or pre-1970 NFL wins the Super Bowl, and it falls otherwise. So, to get rich, you should invest when an old team wins. Right? No, this is just a coincidence. Don't follow these, although some people do fall into these pits of superstition, and this one's just a coincidence. So how do you establish causality? We have different things that we need to go through to establish it. The first one is find situations where the effect is correlated with a suspected cause. Then find different groups where the presence or the absence of the suspected cause are present. Number 3, find if larger amounts of whatever is causing your suspected cause creates larger amounts of effects. Number 4, check all other possible causes and make sure that the effect still remains. Number 5, check with an experiment. Now sometimes if there's life situations, you can't put somebody's life in danger, and so you need to use something like a computer model. And number 6, try to determine the actual physical mechanism which the suspected cause produces the effect. For example, in the 1990s, children were dying in low-speed collisions. And what they ended up doing is providing an experiment with crash test dummies that showed the impact from the airbags was actually hard enough to be fatal to infants and children. So what they did is they actually determined the physical mechanism of the suspected cause, and it produced the effect of these low-speed collisions and the mortality of the children. Now, the last one is confidence in causality. There's the possible cause, that the correlation exists. You can't say it's a cause, but that's what makes you start investigating. The next is probable cause. There's good reason to support the cause, and some of these guidelines up here may have been satisfied. Maybe you found different groups where the presence or absence of the suspected cause either caused greater or lesser effects. And number 3, cause beyond reasonable doubt. You actually have the physical model that explains the cause, and it's unreasonable to doubt the cause, such as in the 1990s with the airbags and the children. I hope you join me in our next lecture, and good luck on your homework.